Well, hello YouTubers and computer nerds everywhere. I have plunged headfirst into the field of retro computing, so I've got multiple projects going on, which is the kind of the way I operate. I never seem to finish one project before starting another, so I've been releasing a series of videos on trying to resurrect the old Teletech System Master S100 computer that I've got. And I'll put a link up here in the corner where you can see the first in the series and then work your way through the rest of the series if you like. But I've got other things going on too. I bought a little kit computer. Well, not so much a kit, just a circuit board. And then I have to find all the pieces to populate it. And here's a look at the circuit board I bought. So I've got to find all the bits and pieces I need to build this little single board computer. And well, one of my hobbies is, if you watch my videos on my channel, you know one of my hobbies is getting precious metals out of old electronic equipment. So I'm always rendering down electronic equipment for their gold. But I will keep interesting or useful bits and pieces rather than just rendering them down for their gold. So I have some Z80 microprocessors here, and I need a Z80 for my little single board computer project. So these are Z80s that I have salvaged from old electronic equipment on the way to getting rendered down to its gold. And I built this little testing jig right here to test them to see if they work, so that maybe I can reuse them. And it's a pretty simple setup here. I've got a 555 timer chip over here that's putting out a square wave. Right now I've got the frequency really low. And it's feeding into the clock input on the Z80 chip. The Z80 chip is, of course, cooked up to 5 volts and ground. I've also got 8 pull-down resistors here, pulling down the data lines on the Z80. So here's a pinout of the Z80. So we've got the 8 data lines over here, and I'm pulling them down with pull-down resistors. We've got some inputs that go to the Z80 that need to be pulled up. Interrupt and non-maskable interrupt, they need to be pulled up, so I've got them with pull-up resistors here. And over here we've got the wait, the bus request, reset. Those are all pulled up as well with resistors. Plus I have a push button that will ground the reset line. I hold it down a little bit, the Z80 will reset and then start doing its thing again here shortly. So it's a pretty simple circuit. And then what I did was I took the lower 8 address lines out through current limiting resistors to drive these 8 LEDs out here. And I have also some LEDs on some of the other Z80's output lines. I have an LED on the memory request line, that's this yellow one right here. I have an LED on the refresh line, that's this yellow one here. An LED on the M1 line, that is this red one here. And an LED on the read line, which is this one right here. So what's happening here, by pulling all 8 of the data lines down and then running the Z80, what it's doing is it's trying to read from memory, which it has no memory attached to it, but it doesn't know that. It's pretty dumb. So it's trying to read from memory, read an opcode or instruction from memory. Well, that instruction is going to come in as 00 in hex. And 00 for the Z80 is a special instruction called a no-op, or no operation. So it's just not going to do anything for, the next 4 clock cycles, except increment its address register and then go fetch the next instruction. Well, the next instruction is going to be another no-op because the data lines are still pulled down. So it's just going to increment its address register, and then, you know, we're going to go through this. Every 4 clock cycles, we're going to go through this. And what's neat about this is that it's a nice little testing jig, because it tests a lot of the functions of the Z80. Now, I could have brought out the other 8 address lines and put LEDs on them, but yeah, I can tell it's working with just the lower 8. Besides, I didn't have enough green LEDs. Okay, I didn't have 16 of them, so I'll have to work on that. But it's obviously working. So this is a 6 megahertz Z80 that I salvaged from some equipment that got torn apart and rendered down for its gold, but I kept the good stuff. Okay, so this one's working. I've got 2 other chips here that I would like to test. So let me turn it off, and we'll pull that chip out, and we'll test these other 2 and see if they're any good. We'll pull this one out carefully without damaging the legs. This one's good, so set it up here like this. So here's a 2.5 megahertz one that was salvaged from some equipment. Let me get it in here, get all the legs lined up. And that's perfect. Okay, let's give it a shot. Hit the reset button, and that's not a good sign. That is not a good sign. I don't think this chip's any good. All the address lines are high. The M1 line is staying high, but nothing else is happening. I don't think this chip's any good. So this 2.5 megahertz chip apparently is shot. Okay, so turn this off again, and let's swap out chips. So this one's dead. We'll put it in dead bug mode upside down over here, so I know that one's dead. And then here's another 6 megahertz chip that I pulled out of something. I don't remember what. Every once in a while I get stuff with nice microprocessors in it. The legs on this one are a little bit wonky. They don't want to go in. I don't want to force it. Don't want to end up breaking or bending any of the legs. I just want it to go in there nicely. Okay. There we are. Took a bit of fiddling, but I got it in. So let's try this one. Oh, it looks like it's working. And you have to hit the reset button. Sometimes I have to hit the reset button for it to start up. But it's working good. Okay. So that's nice. And I can crank the speed up on the 555 timer down here, where you really can hardly even see the orange LED flashing anymore. And you can see it counting across the address lines up here. And these other things are flashing so fast it's hard to make sense of them. But I'll tell you what, if you turn it back down to where it's going really, really slowly, and you have a look at the timing diagram for the Z80, you can see that all this stuff is matching the timing diagram exactly. Like this is the memory request line. And you can see on an M1 cycle, which we're on because the red light came on, so we got an M1 cycle. You can see that the memory request line goes low twice during an M1 cycle. And I have this one hooked up so it comes on when it's active low. In fact, all of these chips, all these LEDs, this one, this one, this one, this one, are all wired up so they're active low, because all these signals here are active low. So you can see that it looks like memory request, and it looks like M1 should be the first to go low. Then memory request and read should go low. And then the refresh signal will go low. And if you look at it, that's the sequence that they're operating in. So it's perfect. It's absolutely perfect. Once you slow it down this slow, you can see how it's working. But then once you speed it up, You know, it's not so obvious anymore which LED is coming on first, and you know which one's staying on longer, that sort of thing. Once you really slow it down, you can see that it really matches the timing diagram nicely. So that's interesting. Yeah, interesting to nerds like me. But anyway, okay, so I've got two good Z80 chips. I've got this, and they're both 6 megahertz chips. Okay, so I can go ahead and I can build my little single board computer. At least I got a few more parts to accumulate, but I think I've got most of them now. Now this little testing jig, this is really handy for testing microprocessors, not just the Z80. The 8080 and the 8085 both share the same instruction set essentially with the Z80. The Z80 actually has builds on the instruction set that they use. But those other two processors, 8080 and 8085, have 00 hex for their no-op instruction too. Now the pinouts on the chips are different, but you could just rewire this and you could test those chips the exact same way as I'm testing a Z80. So you can build yourself a microprocessor tester pretty easy to test out those old chips. And it's not just the 8080 compatible series of chips. I mean, just about every microprocessor, in fact, I think every microprocessor has a no-op instruction. Now, it's not always 00 hex. A lot of them it's something else. But that's easy enough to wire up with just pull up and pull down resistors on the data lines. And you can build a tester for just about any microprocessor, which what got me thinking about this was because I have the opportunity to buy a large pile of old school 68,000 microprocessors. And I don't know if they're any good or not. If they're no good, they'll get rendered down for their gold. But if they are good, they're worth a little bit more on the resale market. So I may build a tester for them if I buy them, just to test and see how many are good and sort out the good from the bad. So that's what sparked this whole idea. And then I got to thinking, oh, I've got these Z80s I've salvaged, and I need to know if they're any good for my little single board computer projects. Let me build this little no-op tester for the Z80s and see if I can sort them out. So now I know I've got 2 good ones and 1 bad one. Actually, I think I have a couple more floating around somewhere. I need to find them and test them. So now that I've got this up and running, and I had a little fun building it. I mean, it's a nice rainy day project. It's been raining for like 2.5 days straight. I'm stuck indoors, so it's a nice little rainy day project to build. But, you know, as I'm building it, I'm thinking, well, I've got 2 retro computing projects going on already. You know, I've got the Teletech System Master I'm trying to resurrect, and I've got this single board computer I'm trying to find the parts for, and I got to start building. Why don't I just dive right into the deep end and start a third project? Maybe a breadboard home design computer of my very own. It's a project that I wanted to take on when I was in college, but I just didn't have the time to get around to it. So now that I'm old and retired, maybe I can actually build myself a breadboard Z80 home-built computer of my own design, and maybe even take a stab at writing my own monitor for it. It's something I wanted to take on a long time ago and just didn't get around to, and now, well, you know, why not? There's a lot of room left on this breadboard. I can get some RAM, some ROM, serial I/O, parallel I/O. Yeah, I think I'm going to do that. So I think once I'm done testing my chips, I think this may become the basis of a breadboard home-built computer. So I need to sit down and sketch out what I want. Definitely RAM and ROM and serial I/O, maybe parallel I/O. I need to figure out how much memory, you know. I'm not sure, you know, on a first effort of a home-built computer, I don't know if I want to get into bank switching and go beyond 64K. That's a little complicated. There's a lot of examples out there of it. But, you know, that's a little complicated, especially if I'm going to take a stab at writing the code. Maybe we'll keep it simple. Keep it simple. We'll have a Z80. We'll have maybe 2 to 8K of ROM and the rest RAM, all static, so I don't have to worry about refreshing dynamic RAM, although the Z80 has built-in functions for that, which is nice. But still, it's a little extra overhead I don't need to worry about. Couple of serial ports, at least one to talk to a terminal on my laptop, and then some parallel ports for some blinking lights. Yeah, so I think I'm going to sit down and I'm going to design up something. And I don't know how long that's going to take, and I've got these other two projects going on, plus I've got all my other projects going on, plus I've got stuff to do around the farm. So, you know, this is probably going to be a long-term thing. You know, don't hold your breath waiting for part 2 to come out. It will come out eventually, but it may be a little while. So I'm going to design the computer, and then once I got something together, I'll do another quick video on that, and then we'll start building it once I have the components. But right now all my components are kind of earmarked for the single board computer kit that I got. So, like I said, it's going to take a while, but hey, I'm retired. I got all the time in the world. Okay, well, thanks for watching. I hope you found this video a little bit interesting. If you've watched this far, you must have. Give the video a like, give it a thumbs up, subscribe to see future videos, and press that little bell icon that YouTube makes you press in order to get notified when new videos come out. Because there will be new videos on this coming out eventually. There's also going to be videos on the Teletech System Master, videos on the single board computer kit project, and of course lots more gold recovery videos. So, thanks for watching. I'll see you next time. Have a good one. Bye.